Here is a very complicated looking example. Solve the equation 4 over secant squared theta plus 3 cosine theta is equal to 2 tangent theta cotangent theta on the interval from 0 to 2 pi. Now it's very easy to be overwhelmed at first, but it's also important to be able to take a step back and start thinking about what you can do to simplify this. The first thing to recognize is that 1 over secant squared theta is one of the reciprocal identities. This is actually just cosine squared theta. So 4 cosine squared theta plus 3 cosine theta is equal to. Before we talk about the right-hand side, notice that this left-hand side has simplified significantly already by just recognizing that one substitution. You may not see it all at once, but as long as you're making forward progress, that's a good sign. What can we do with this? 2 tangent theta times cotangent theta. Well, once again, we can draw on the reciprocal identities because cotangent theta is just 1 over tangent theta. And so that substitution allows us to cancel out the tangent thetas. And so we have 4 cosine squared theta plus 3 cosine theta is equal to 2. Now at this point, we see that we have a squared term, cosine squared, so we're going to use the quadratic formula or factor, and so we need to subtract 2 from both sides to get this equal to 0. Okay, so we should check, does it factor? AC method. So AC, remember, it multiplies to AC and add to B. So A times C, 4 times negative 2 is negative 8. So two numbers that multiply to negative 8 and add to 3. And so if you play around with this for a little bit, you're going to quickly discover that it just doesn't work, that there are no integers that accomplish this. And so that tells us we can't factor. When we can't factor, the other technique we have is we have the quadratic formula. Now, this is obviously less preferred because it's a lot messier, but sometimes you got to do what you got to do. So in this case, our variable is going to be cosine of theta. I'm going to write out the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. Make sure your fraction bar is long enough to capture both parts of the numerator. So when we make the substitution, our b value is 3. So negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a times c. So 4 times 4 is 16, times negative 2 is negative 32. So it'll be plus 32, right? Minus a negative, all over 2 times a, which is 8. So our cosine of theta is equal to negative 3 plus or minus the square root of 41 over 8. Now at this point, it becomes clear that we're going to need to use a calculator. We're going to need to get a decimal approximation to these values, and we can go forward from there, and I'm going to need more space on my board. So right now, we have cosine of theta is equal to negative 3 plus or minus the square root of 41 over 8. And so we have to deal with the plus case and the minus case separately. Let's go ahead and start with the plus case. Cosine of theta is equal to negative 3 plus the square root of 41 over 8. And so this is going to have to go into a calculator because we really don't have much else we can do with it. And so when we plug it into a calculator, you get cosine of theta is equal to 0.425. Now, obviously, this is not one of the known values, and so we're going to have to use a calculator, and we're going to have to think about the unit circle picture. Cosine of theta, cosine is the horizontal direction. The horizontal direction is a positive number. So that tells us we're going to have solutions in quadrant 1 and quadrant 4. And when you put this into a calculator, you're going to get the value of the inverse cosine of 0.425 is 1.131. Now remember, this is in radians, and 1.131 radians, this is less than pi over 2 radians, and so this will give us our first quadrant value. How do we get the quadrant in the, or how do you get the value in the fourth quadrant? Well, we have to go all the way around and subtract off that angle. So 2 pi minus 1.131, which turns out to be 5.152. We're only interested in the solutions on the interval from 0 to 2 pi, and so we don't have to worry about doing the plus 2 pi k for these. So that takes care of the plus case. What about the minus case? Cosine of theta is equal to negative 3 minus the square root of 41 over 8. When you plug that into a calculator, you get this is negative 1.175. and we draw the unit circle picture. The cosine value is, again, x-coordinate, but the x-coordinate is negative 1.175, which is going to be just outside of the circle. And so this part has no solutions. And so here's an example of solving one of these problems where we ended up using the quadratic formula. The overall process and approach is still the same. But in this case, when we ended up with something that we just couldn't factor, you have no choice. You have to go to the quadratic formula. It gets messy, but sometimes that's what happens.